Once again, thank you. And we continue with the third commercial module manufacturer in the field of TOPCon. We're very happy to have with us now Jolywood, which is actually the pioneer in commercial cell module manufacturing of TOPCon Technology. And we are happy to have with us Dr. Zheren, who is the Cell R&D Director at Jolywood, who will talk about progress and applications of Jolywood's N-type TOPCon technology. The floor is yours. Welcome.
Hello.
Hello.
Okay. Can you see the slides?
Yep.
Okay. Okay, thanks, Mike, for the kind introduction. Good morning, everyone. I'm Zheren from Jolywood. Today, I'm going to give a presentation on the progress and application of Jolywood N-type TOPCon technology. In the first part of the presentation, I will give an introduction of Jolywood Group. Jolywood Group was established in 2008, and it was listed at stock exchange market in 2016. Jolywood Group provides solar backsheet, solar cell and module, B2C service, and EPC service. And Jolywood Hydro Solar Technology is a subsidiary of Jolywood Group. Jolywood Solar was founded in 2016. It has the world's largest N-type cell and module capacity. Yeah. I would like to share our N-type technology roadmap in this slide. Jolywood is one of the earliest company that apply N-type technology to mass production. And we started our first N-type cell structure as an N-PERT cell. It has a very similar cell structure as PERT. The typical mass production efficiency is about 22%. And we have seen the limitation on the efficiency based on this structure. That's why we look for new cell structures that have higher efficiency potential. TOPCon technology in Jolywood started in 2017, and our first generation TOPCon cell has reached 23.5% cell efficiency, and we call it TOPCon 1.0. And then we developed the second generation TOPCon technology, and we call it J-TOPCon 2.0. It has a higher cell efficiency, and most importantly, it has fewer process steps, which make it much more competitive. So till now, our J-TOPCon cell has reached more than 24% efficiency in mass production. And this is our main production technology, and I will focus more on this technology in today's presentation. In the future, we will continue to develop TOPCon 3.0 technology to reach more than 25.5 cell efficiency. With this new technology, the process steps will be further reduced. And we also reduce the silver consumption so that the cost will be comparable to PERC. And we will also develop new cell structure that has even higher energy efficiency potential. And we will achieve more than 26% cell efficiency by J-TPC structure. And this structure is a hybrid structure between the TOPCon and the IBC. Yeah, another future direction is going for tandem cell, and we expect more than 28% efficiency based on this structure. But this probably will be out in 3 years. Yeah, here's the structure and the protection of a TOPCon cell. TOPCon is the short form for the tungsten oxide phosphating contact, and it has a tungsten oxide layer and a doped polysilicon layer. And this structure is very important to phosphate the surface and achieve a very low contact resistance at the same time. And there are a lot of effects on the silicon substrate surface, and silicon oxide provides excellent chemical passivation. And the heavy doping in the polysilicon repels minority carrier, and hence it provides excellent field effect passivation. Yeah. The titanium oxide has very high selectivity. It allows the majority carrier to tunnel through very low to tunnel through the oxide at very low junction resistance. Yeah. The structure takes advantage of the quantum tunneling effect. Yeah. Which is the quantum behavior of electrons which penetrate through the potential barrier. So all these properties enable the cell efficiency beyond 25%. Yeah, since the doped polysilicon layer is the key structure of this TOPCon cell, so we will investigate in more details regarding the poly deposition and the doping methods. So this table actually summarizes the different polysilicon deposition technologies, yeah, which include the LPCVD, PCVD, APCVD, PVD, or PAPAID evaporation. So this PAPAID technology actually is developed by Jolywood. It's very similar to the PVD process. And in the later slides, I will share more details about this technology. Yeah. So firstly, the LPCVD is a very well-proven technology that has been already widely used in the mass production of a TOPCon cell. So actually, we found that the main drawback is the wraparound of the polysilicon layer. And PCVD deposition of polysilicon has been demonstrated in the lab scale. And PCVD is possible for single-site deposition. So although the industrial tool is available, but it's actually not yet widely used in the mass production yet. And PVD and the PAPAID technology is one of the best technologies that suitable for single-site deposition. But it is not yet applied in the large area industrial cells. Yeah. And for the other technology, for example, the APCVD and the evaporation, there's not much information about these two. For different polysilicon deposition methods, self-processing flow is also very different. Yeah. So this is the cell process flow chart, which shows the most frequently used process flows. So for LPCVD technology, with or without in-situ doping, this wraparound removal process is essential. And the removal process is very difficult because it's very difficult to control. And it may cause some yield issues with other visual defects, and also some negative impacts on the cell efficiency. Yeah, so for PCVD and recently there's a PLD technology. They have much less wraparound, but still they need a wraparound removal process. But this wraparound removal process is much easier to control. And for the PVD or PAPAID technology, there's absolutely no wraparound. So the wraparound removal process is not required, but we still need a very simple hydrofluoric acid cleaning after the annealing. And this is the introduction of the PVD technologies. Actually, the first application of PVD technology in TOPCon cell process was done by Australia National University. They actually achieved 23% cell efficiency, which demonstrated the possibility of this technology. And followed by Constance ISD and Von Aden. They also did some research work on PVD technology for both TOPCon and HJT cell structures. They have the industrial type PVD tools, but this technology is not used for mass production of TOPCon cell yet. So for TOPCon structure to achieve a very good selectivity, it needs to have a very low saturation current and also very low junction resistance at the same time. So the left graph actually shows the status of P-type doped polysilicon deposited by LPCVD, PVD, and PCVD. You can see from the graph that the saturation current and junction resistance are very comparable for all of these three technologies. So on the right, the graph shows the status of N-type doped polysilicon deposited by LPCVD, PVD, and PCVD. The saturation current for PVD technology is low, but the junction resistance range is pretty wide. This is also one of the challenges in the PVD process. The Jolywood has already developed PAPAID technology and also applied it in our J-TOPCon 2.0 cell process flow. The PAPAID actually stands for plasma oxidation and plasma assisted in situ doping deposition. It's actually the first time that this technology is used for TOPCon cell mass production, and also the first time applied on a large area TOPCon cells. PAPAID process actually is an inert process. The color oxide is more uniform compared to the standard process. So in this process, we ensure that there's no poly wraparound, so that no additional poly cleaning process is required. In addition, in situ doping with high deposition rate has also been achieved with this new technology. So with this new technology, we have achieved higher efficiency and yield, and also lower cost due to the reduction of the process steps. We also summarized efficiency records on N-type TOPCon solar cell with different polysilicon deposition technologies. Yeah. The TOPCon with PCV technology was first developed in 2013. The highest efficiency so far is 25.8% reported by Fraunhofer 2 years ago, and for the TOPCon with LPCVD technology, PINCO has reported 25.4 on large area cell this year. And for TOPCon with PVD or PAPAID technology, the efficiency started with 23%. And Jolywood has also reported 25.4% on large area cell this year. And this shows the potential of this new technology. So actually we have applied our TOPCon 2.0 technology on large wafers, and we are able to provide both M10 and T12 size cells. Yeah, the new technology and the large wafer actually make our J-TOPCon 2.0 products more competitive. And our product has very high module power. The module power is more than 570 watt for M10 size with 144 half cells. This is about 30 watt higher than the standard PERC modules with the same configuration. And we also have module power more than 700 watt for G12 size with 132 half cells. The module power for M10 size with 108 half cells, the module power is more than 430 watt. And also our product has very low degradation, high bifaciality, high reliability, and low temperature coefficients. These properties contribute to an increased electricity generation during the module life cycle. And according to our calculations, 30 watt module power increase will lead to like around 1.5% LE COE drop. 10% higher bifaciality will lead to about 1% drop in LCOE. And the lower temperature coefficient will lead to about 1% drop. And also the lower degradation will also lead to 2 to 3% LCOE drop. So in total, we expect 5 to 10% the LCOE drop. And we have some N-type solar power plant projects already installed in different provinces in China. And we also have some projects abroad, for example, the Middle East and Europe. Some of these locations with very high temperature or very high humidity actually is very desirable for N-type products. Actually, till this year, Jolywood has about 5 gigawatt N-type cell and module shipment. And from this map, you can see that our products covered a lot of countries globally. So we are also looking forward to our new customers and collaborators in the future. Yeah, that's all for my today's presentation. Yeah, thank you.
Darren, very nice. Great to see your further developments in the field of TOPCon. Happy to have you with us. I think there are a few questions in the chat. Maybe you can answer it there so that we can move on here with the presentations. Thanks again for your great presentation.